Okay, so we're going to talk a little bit about graphing linear inequalities. Now, the first thing that you need to do is you need to know how to check whether an ordered pair is a solution or if it's not a solution. So how you do that is we're going to take this first equation up here. So we've got 2x plus 3y. So 2x plus 3y is greater than or equal to 5. So let's see. We've got 2x plus 3y is greater than or equal to 5. Okay, so the first thing that we're going to do is we've got this ordered pair 0 and 1. So 0 and 1. So then we're going to go ahead and put this in. So we're going to sub in 0 for x and 1 for y is greater than or equal to 5. So right here we've got 3 is greater than or equal to 5. Now, this is false because 3 is not greater than or equal to 5. So we would say that 0, 1 is not an ordered pair of 2x plus 3y, which is greater than or equal to 5. Okay? Now what we're going to do is we're going to figure out how to specifically graph these linear inequalities. So if you can see, number 1 says to graph the line, so you need to rewrite your equation into the y equals mx plus b form. Now, it's going to be a dotted line if it's less than or equal or greater than without your equal to underneath. If you have your equals to underneath, then it's going to be a solid line. So let's start with this first example. It says graph y is less than a negative 2. So y is less than, and if you can see it's less than a negative 2. Negative 2. So let's go ahead and draw our graph over here. So 0, 1, 2, 3, 4, 5, 0, or I'm sorry, negative 1, negative 2, negative 3, negative 4, negative 5, 1, 2, 3, 4, 5, and then negative 1, negative 2, negative 3, negative 4, and negative 5. Okay, so our first ordered pair, we're just going to plug in 0 and 0. Okay, but first we need to actually plot our vertex. So our vertex is at a negative 2. So here is a negative 2. Now, we don't have a slope here, so we're going to just go ahead and go over 1, up 1, and over 1, up 1, or down 1. Okay, now our line does not have an equals to underneath, so it's going to be dotted. So we're just going to go ahead and dot this line. Okay, then what we're going to do is we need to see 0, 0. So what we need to see is this going to be true or false? So let's plug in our 0. So 0 is less than a negative 2, which is false. So we're going to go ahead and shave in this line here. Now, our second example is x is less than or equal to 1. So we've got x is less than or equal to 1. Now the first thing we need to do is we need to plug in our x. So here we have x is less than or equal to 1. We don't have y. So we're going to plug our 1 into our x-axis instead of our y-axis. Okay? So here we go. Again, we've got our map. We've got our graph. So here's our x-axis right here. So we're going to go ahead and plug in x is 1. So we're going to go ahead and plug in 1 on our x-axis. Now, because we've got our equals to underneath, our line is going to be solid and it's going to go right through our point. Okay? Now we need to see, is this true or is it false? So again, we're going to use the point 0, 0. Since we don't have a y, we're not going to use the y, but let's plug in 0 for x. So 0 is less than or equal to 1, which is true. 0 is less than or equal to 1. So because it's true, we're going to go ahead. Oh, actually, over here, because the point's on our x-axis, we're actually going to draw our line this way. And since this is true, we're going to go ahead and shave it in on this side. Okay? Now our second example is 2x minus 5y is greater than or equal to 10. So we've got 2x minus 5y is greater than or equal to 10. So is greater than or equal to 10. Okay, so let's go ahead and draw our graph. So 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And negative 1, negative 2, negative 3, negative 4, and negative 5. Okay, so now, here we go. Let's look at this. So what we need to do is we need to actually get y by itself, because we need to find what our y value is. So we're going to minus 2x. So we're going to minus 2x from both sides. And we've got, and remember our x actually goes first because we have the y equals mx plus b form. So we've got a negative 5y is greater than or equal to 10 minus 2x. Then we're going to go ahead and we're going to put this in y equals mx plus b form, which is a negative 5y is greater than or equal to a negative 2x plus 10. Then you're going to divide a negative 5 by both sides to get y by itself. Now, when you divide by a negative 5y, or negative 5, we actually need to switch our sign here. So we're going to divide by a negative 5, and then we're going to switch our sign. So we've got y, and a negative becomes a positive. You also need to switch our sign. So y is less than or equal to 2/5 x minus 2. Okay, and then to get just the y intercept, we're actually going to plug in the 0 for your x. So we've got y is less than or equal to, and remember we plug in our 0 for our x, negative 2. So negative 2 is where we're going to start, and we're going to plot our vertex. So negative 2 goes on to the y-axis. So this is the y-axis, and we're going to plug in a negative 2. And then what we're going to do is we're just going to, again, because it is less than or equal to, our line is going to be dotted, or is going to be solid. Okay, and then what you're going to do is you're going to go ahead and you're going to take a look right here at your slope. And so what we're going to do is we're going to actually plot our other lines with our slope. So here we've got, if you can see, down here our slope is 2/5, and it's a positive 2/5. And again, it's rise over run. So we're going to go up 2, we're going to rise 2, and we're going to go over 5. So up 2 over 5. 1, 2, 3, 4, and 5. And then we've got down 2 over 5. So then down 2 over 5. And then we're going to go ahead and we're just going to plot our points and make sure that the line is solid. And the reason why it's solid is because it's got less than or equal to. All right, now what we're going to do is we're going to pick our points. But we're going to start with our original equation. We're going to go back to our original equation up here. And the points that we're going to use is 0 and 0. So we're going to plug in x 0 and y is 0. So then we've got 0 is less than or equal to, or is greater than or equal to 10. And the reason how we got our 0 is because we plugged in 0 for x and 0 for y. So we've got 0 is greater than or equal to 10. Now 0 is not greater than or equal to 10. So we're going to just go ahead and we're going to shave false because this is false. Okay? Okay, so we're going to look at our last example. Our last example is 3x minus y is less than 3. So first thing we're going to do is we're going to draw our graph. So we've got 1, 2, 3, 4, and 5, and 1, negative 1, negative 2, negative 3, negative 4, negative 5, 1, 2, 3, 4, and 5, and a negative 1, negative 2, negative 3, negative 4, negative 5. So let's look at our equation. Our equation says 3x minus y is less than 3. So 3x minus y is less than 3. Now, we need to get it into the y equals mx plus b form. So we're going to minus our 3x, and we're going to minus our 3x. And then we've got a negative y is less than 3 minus 3x. Okay? Now what we're going to do is we need to have it in y equals mx plus b form. So we're going to switch that. So a negative y is less than negative 3x plus 3, because we need it into y equals mx plus b form. Now this is negative, so we need to get rid of the negative. So we're going to divide by a negative 1 to get rid of our negative, and then we're going to divide by a negative 1, because whatever we do to one side, we have to do to the next, so we can get rid of our negatives. And we end up with y is less than, and then a negative is a positive, so 3x plus 3. Okay? Now we need our y-intercept form, or our y-intercept point. So we can make our x equal to 0. So we've got y is less than 3. So we're going to go ahead and plot our point at 3. And then here we've got our slope, which is 3 over 1. And again, it's rise over run. So we're going to rise 3 and go over 1. So rise 1, 2, and 3 and over 1. And then we're going to go down 1, 2, and 3 and go over 1. Okay? Now we don't have an equals on the bottom here, so our line is going to be dotted. So let's go ahead and dot our line through our points. Okay? Now, our y-intercept form here was that if we go down our y point was at, so this should be a negative 3. So let's change that. So this should actually be a negative